Alright, in section 12.3 we talk about two more integration rules. First one is taking the integral of e to the u du, as well as 1 over u du. Alright. So the first formula we talk about is if you get something in the form of e to the u times du prime dx. So you pick whatever your exponent is for your e, you take the derivative of that, and you somehow rearrange things so that you have that u prime there, and then tag the dx on the end. And then it's just simply your integral answer is just e to the u plus c. That's it. Alright, so integral of 5e to the x, you can bring the 5 out front. And e to the x dx, it's already in the right form, because if this is your u, if u equals x, the derivative of x is 1. And there's a 1 there already. So you can just take the derivative of that and you just get e to the x, with the 5 out front, of course. And this one, when you evaluate a, you let u be x squared. So then if u is x squared, u prime is 2x. And so you got the 2x there. And so you got the e to the u, you got your u prime, and you got your dx, exactly what you need. And so that gives you e to the u plus c. You plug in what u is, and you got it. This one, you let the exponent of the e be your u, or actually you rewrite this with e, with the negative x cubed. You let that be your u, and then your u prime is negative 3x squared. Well, you got the x squared part, you just need the negative 3 there. So if you put a negative 3 on the inside, you got to put a negative 1/3 on the outside. So now you got your e to the u prime dx. E to the u prime dx. So you just get, you have the 1/3 out front, of course, but your answer is just e to the u. And you replace what u is, and you got your answer. And I just cleaned it up by bringing the term across the fraction bar, making it a positive x cubed. C, if you're taking the x squared as your u, then your u prime is 2x. And so you got your e to the u prime, and dx, and you're ready to go. There you go, e to the u. Replace u with what u is. You let u be negative 3x, so your u prime is negative 3. So you got e to the u, and you got to get a negative 3 dx here. So if you put a negative 3 there, you put a negative 1/3 out front. And so now that's just e to the u prime dx, which is perfect form you want. And so it's just e to the u with the minus 1/3 out front. And you replace u with what u is equal to. E, we can bring the e to the 3x up and it makes it negative 3x. So then let's let u be negative 3x, so our u prime is negative 3. So we need a negative 3 here, so we're going to put a negative 1/3 out front. And so now we're ready to integrate, and we get negative 1/3 e to the u, and u is negative 3x. With this one, you let u be 3x plus 1, so your derivative is just 3. So you already have the 3 there, so you don't have to do anything. It's ready to go, and you just get e to the u, which is 3x plus 1. Example 3, they give you the derivative and they ask you to find the original function, so you have to take the integral. So the integral of dv dt is 15.4 e to the 0.077t dt, and you let this exponent be your u, then your derivative is 0.077. Alright? So you bring the 15.4 out front, you insert the 0.077 that you need for the u prime, and if you insert that, you got to include the 1 over that to cancel it out. So now when you multiply those two together, eventually when you simplify that down, it actually reduces down to the exact number of 200. This is e to the u prime dt, so you get e to the u prime dt, and when you integrate, you get e to the u. And your u is 0.077t. Now, they tell us that at year 0, the cost of the house is $200,000. So plug in t equals 0 into the function, and you'll get an answer that's in thousands. So if your answer is 200,000, you would expect it to be 200. So you set v of 0 equal to 200, and it allows you to nail down what c is, and c ends up equaling 0. So your general answer becomes the specific answer. Now they ask you to plug in 10 and see what you get. And remember, that's in 100,000s, so or thousands, so you get 431,950. Now here's the other formula that we learned, which is the integral of 1 over u du, or 1 over u u prime dx, is going to give you ln of u plus c. And if you have a simpler form, just 1 over x dx, it's just ln of x, and it's the absolute value of x, because we have to make sure that we don't plug in a negative into the natural log. Logarithms can't take negative numbers. They have to be positive. So we're forcing it to be positive that way. Alright, so this one is 4 over 4x plus 8 dx, and so if you let that denominator be your u prime is 4, which your numerator already is, so you got it in the right form. You got your u prime on the top, you got your u on the bottom, and you got your dx off to the side. It's perfectly ready to go. So now you get ln of absolute value of u plus c, which is 4x plus 8 is your u. And here's the graph of many different families of this function for different values of c. Number 5, you take this denominator to be your u, and then your u prime is this guy. When you factor it, you get 2 times x minus 3. Well, you got the x minus 3 already. You just need to put a 2 in there. So when you put a 2 in there, you got to put a 1/2 out front. And so you get 1/2 u prime over u dx, and so it's just 1/2 ln of absolute value of u plus c, and you replace u with what u equals. Population growth, this one's a little tricky, but they want you to integrate this integral here, or take the integral of that. The first thing you want to realize is that you let your denominator 40 minus p equal u, so your u prime is just -1. And so if you put a -1 on the top, you got to put a -1 on the outside to cancel each other out. So now you've got u on the bottom, you got u prime on the top, and you got your dp out there, so it's ready to go, and you take the integral and you get the natural log of u, absolute value of u, and u is 40 minus p. Now when they simplify this, they want you to solve this for p. So first we know that 40 minus p is positive, based on the question. If you read the question, you'll see that it's positive. And then they subtract c, they multiply by negative k, and then they distribute the negative k here, and then they just rewrite this using logarithms. Base e of this exponent equals 40 minus p. And so you get this guy, and you subtract 40, and then multiply by -1, and you get your answer. Now in example 7, this talks about if your numerator is greater than or equal to the denominator's degree, do long division first, and then you'll be able to answer a problem you wouldn't have been able to do otherwise. So long division, remember each place has to be represented here, so if there are certain terms that aren't represented, you put a 0 in its place. And now you say x squared times what gives me x to the 4th? Well, it's x squared. And now you multiply that times each one of these, and when you do, you get x squared times x squared is x to the 4th. You get x squared times -2 is -2x cubed, and then you subtract. So x to the 4th subtract x to the 4th is 0. -2x cubed subtract -2x cubed is really -2x cubed plus 2x cubed, which is 0. And now you bring everything else down. And now x squared times what gives me 4x squared? Well, it's 4. And now 4 times each of these gives me this here. And again, I subtract 4x squared, subtract 4x squared is nothing. -7x squared subtract -8x is -7x plus 8x is positive x. And I bring down the 1. Now you can't divide x squared into x, so you stop at that point. And this is your answer, and this is your remainder. And so you put the answer plus the remainder over your divisor. And so this guy does equal that. And so this integral equals this integral. And we can do the integral of each one of these separately. These first two are not that much of a problem. The third one, you're going to have to do the substitution here with u and u prime. So you let u equal the denominator, u prime equals 2 times x minus 1. Well, you need a 2 there. So if you're going to put a 2 there, you put a 1/2 out front. So now this becomes u prime over u dx, which is what you want. So you get ln of absolute value of u. And remember, u is x squared minus 2x. So that's what you put in there. And when you integrate x squared, it's just x cubed over 3. When you integrate 4, it's just 4x. And you get your constant there. Number 8, if you want to integrate this guy, you let the denominator be your u, and your derivative is 3x squared, which is exactly what you got here. So it's already in the right form, and you just take the natural log of absolute value of u plus c, which gives you this. Here you let u equal x squared plus 1, so your derivative is 2x. But you want to write this guy to the 1/2 and bring it up top, makes it negative 1/2. And so this becomes, that's your u to the minus 1/2, and the 2x dx is your u prime dx. So now, when you integrate that, you're going to add 1 to the exponent and divide by that new exponent, and plus c. So you get u to the 1/2, and when you flip the 1/2, it's really multiplying by 2. And that is the square root, and we plug in what u equals. On this one, we can write this as, we can write the 2 out front, so this is just 1 over x dx, which is u and u prime dx, so it's ln of u. And your u is x. On this one, you got to do long division, and when you do, you get 1 with the remainder of minus 1. And remember, it's your answer plus the remainder over your divisor. And so you integrate each one of these, and you can see how it works out, and we get our answer that way. Alright, so 12.3, I think there were about 15 problems or so. Let's look at the first one. 3 e to the x dx. Let's let the exponent be our u. So our u prime is 3, and we already have that. So we have our e to the u, and we got our u prime dx. So we got exactly what we want, and our integral is just e to the u, which is the 3x. Here we got u is 2x, so our derivative is 2, and we don't have the 2, so we put a 2 in there, and we put a 1/2 out front. So we get e to the u prime dx, and we get e to the u plus c, and u is 2x. Number 7, you can bring the 840 out front, and you can let this exponent be your u, so your u prime is negative 0.7, which you don't have. So if you're going to introduce negative 0.7, you got to also introduce 1 over negative 0.7 to cancel each other out. And so this will give you, it turns out this gives you negative 1,200. This is e to the u prime dx, and we just integrate that and we get e to the u. And our u is this guy here, so there we go. Number 9, if we let the exponent be our u, we get our u prime is 12 dx, or 12x cubed. We don't have the 12, we have the x cubed, so you got to put a 12 there and a 1/12 out front. So now you're ready to go, you integrate, you get e to the u, and you replace e to the u with what it is, 3x to the 4th. On this one, you let u be negative, or actually you rewrite this with a negative exponent, bring it across the fraction bar, it becomes negative 2x. So now if you let u equal negative 2x, your u prime is negative 2. Well, you got 3 there. So bring the 3 out front, put in a negative 2 that you need, and then outside put a negative 1 over 2, the reciprocal of what you have there. So now this is just e to the u prime dx. And so you get e to the u plus c. And there you go. Alright, with this one, you can integrate each one separately. With this one, you let your u be 4x, so you need a 4, and you put a 1/4 out front. For this one, you let u be minus 1/2, so you need a minus 1/2 inside, so you put a minus 2 outside. And when you integrate, you get e to the u. Here you also get e to the u. And you got your constants out front, so you get 1/4 e to the u where u was 4x, and you got positive 6 e to the u where u was minus 1/2 x. 17, you let your denominator be u, you let your numerator be u prime. It's ready to go. You get natural log of absolute value of u plus c. Here you let u equal 4z plus 1, so your derivative is 4. So you put a 4 in there and you bring a 1/4 out front. So now you've got u prime u dz, so it's ln of absolute value of u, whatever u was. Here you've got denominator is 2x to the 4th plus 1. That's a derivative of 8x cubed, so you need 8x cubed, not 6. So bring the 6 out front, introduce an 8, and outside put a 1/8. Multiply that together, you get 3/4. When you take the derivative of that, you just get ln of that of your u, which in this case was 2x to the 4th plus 1, and you have the plus c as well. So you let your denominator equal u, your numerator is supposed to be this, and we've got the z squared plus 1, we need the 3. So if you put a 3 there, you put a 1/3 out front, it's in the right form, so now you can integrate and you get your answer. 43, they give you the derivative and ask you for the original function, so that's integration. So you bring the 6 out front, you let the exponent be your u, so you need a 0.01 in there. So when you put a 0.01 in there, you put a 1 over 0.01 outside. So when you multiply 6 times 1 over 0.01, you get 600, and that's e to the u prime dx, which is just e to the u plus c times 600. Now we know that when you sell 0 items, you make 0 revenue, so r of 0 equals 0, and you can plug in 0 into this function. And this is times 0, so it's just an exponent of 0. Anything to the 0th power is 1. 600 times 1 is just 600. So you end up realizing your constant is negative 600. So you take your answer and you replace the constant with what you know the constant should be. So now when they ask you to check out when you sell 100 products, you know what you're going to the answer you're going to get, which is $1,030.97. 47, they give you the derivative and ask you to integrate that. Okay, so if you let u be t plus 1, your derivative is just 1. And so you bring the 40 out front and you got the u prime up there and you got your u down there and you got your dt there, so it's ready to go, and you get ln of whatever u was. Here, if you let t is the number of hours of study and v of t is how many words they memorize. So if you've studied 0 hours, you've memorized 0 words. So v of 0 equals 0. And you plug in 0 for t and you set this thing equal to 0 and solve. Ln of 1 is actually 0. And so 0 times 40 is 0. So 0 plus c equals 0, c has to equal 0. So this function, the c just basically goes away because it's 0. So there's your function, and they want to know how many words you'll memorize in 3 hours, and so you plug in a 3 there, and so you've got 40 times ln of 4, which is approximately 55 words. On this one, again, they give you the derivative, so you got to integrate, and if you let the exponent be your u prime is 0.1, which you already have. And so you can bring the constant p outside, and this becomes e to the u, and there's your u prime dn. So when you take the derivative, you just get e to the u plus c. And you let u be 0.1n. For b, they say, in how many years will the future value double? Well, p is your initial investment, so doubling means 2p. So when you solve this, you can divide both sides by p, and you get this. You can take the natural log of both sides and you get ln of 2 and you get ln of e to the 0.1n, which means ln of e to an exponent is just the exponent by one of the log rules. And then this is 1/10, so if you multiply by 10, you get rid of that 1/10. So now you know n is 10 times natural log of 2, which is 6.93 or approximately 7 years.